right, is that working?
Yep.
So about 6 months ago, my wife and I decided it was time to tear down our garage before it fell down on its own. So this is what it looked like when we bought it about 2 years ago. And it's kind of hard to tell by the picture, but the back wall where that snowblower is kicked in about a foot because the earth is actually pushing the garage in. So there was probably about 4 studs that were actually touching the ground, and the rest of it was just structural siding and masonite that was on the inside. So we decided to start taking it apart. So obviously the first thing you do before you tear your garage down is build a shed. So this is our temporary shed that we're kind of using. So that went up in an afternoon and helped us start to take this old garage down. What's kind of interesting about this structure, it was pretty well built in some ways and had electrical run to it, plumbing run to it, crown molding, paneling. And as far as I can tell, the original owner of my house built this first, got a street address for it back in 1928, and then used that to live in while he built the house. So it's kind of sad to take it down, but had to go. So wife designed new garage, got it through permit, and then at the very last minute we decided to change the plan, add a dormer, move the windows around, and then resubmit it for permit, and this is what we built. Starting from the top, just taking the shingles off, and fun way to do that is you cut a hole in the roof and you climb out through the middle, so you don't actually have to put a ladder up on the outside, and you can take it all down. So that was relatively quick weekend's work. You're gonna see a lot of wood here that's gonna come back at the end. You can't really reuse wood for construction unless it's been graded, and back in 80 years ago they didn't grade wood, but it's really nice stuff. So as we were taking it apart, we tried to save as much as we can. Let's see.
Go.
A lot of block and tackles. This was what of the wood that we didn't end up saving. This is an entire 20-foot by 20-foot garage. Fills up a 20-yard dumpster, if you're curious. Chris was kind enough to come over for the weekend with his Bobcat, which was extremely helpful when you see how much concrete actually was there. So he made quick work of getting rid of the slab. Turned out our actual foundation, well, so there's the slab. That's a 10-yard dumpster, but I was a little nervous if he was going to be able to lift it. They normally tell you don't fill a dumpster more than half full of concrete, but no problem. We ended up keeping the existing foundation, but I wanted to undercut it. So I just put a 90 on a pressure washer to cut through the mud. And it actually turned out there's quite a bit more impressive foundation than we originally expected. So what you're seeing there was at each corner of the foundation, and then in the mid span, there's we basically poured a 12-inch by 4-foot deep concrete column that's supporting what will be the future wall here. Basically, rather than digging out all existing concrete, there's enough there, and then by reinforcing it, we were able to save that, which saved a lot of cost and work removing all of it to effectively give us a frost protected foundation. So a lot of rebar. Chris made fun of me, but I feel good about that wall not caving in anymore. As you can see on the side of the picture there, the grade is up about 2 feet. So that's the top of this plywood is just there. This was roof sheeting that we saved. That was from a repair on the garage earlier, and this will come back into the garage at the end as well. So more form work, a lot of bracing. Notice when I'm sitting over here in the corner, I really should have put more bracing in there, as I'll show you later, but almost had a catastrophe. But through bolted the bottom of the forms so that wouldn't blow out, and then just put as much bracing as we could. But we wanted to keep the inside open so that when we started pouring, we had room to work in there. So got everything set. Jim and Chris and Davey were kind enough to give a hand for a day and filled all the walls. Again, makes quick work when you have a Bobcat. Considering my driveway here too is like that's about as close as I could get this dump truck or cement truck to the drive. So it would have been a lot of wheel bearing if we didn't have the Bobcat here. That's a vibrator that you stick into the forms to help get rid of the air bubbles and kind of slump out. And it was pretty amazing what it would do. You could see, you would think the form was full, and then you ran this vibrator through it and you would drop 2 inches, and you made a pretty significant difference. Here, right where Christy's standing, that's the door buck. So there's no concrete there because that's where the future person door is going to go. So end of the day, things were looking pretty good. One spot in this upper left of the photo, definitely not enough bracing, and that wall almost bowed out. It actually did almost blew out. It bowed out about 2 inches, which affected the final thickness of that wall a little bit. A little more concrete in that corner. This is just kind of a nice proof of success. That green line is my laser, and it's just skimming over the top of the wall, so at least the back wall is level. So this is a good chunk of the old garage, as much as framing that we could kind of save and salvage, which we then spent probably 3 days denailing to hopefully reuse into something. At this point, we weren't quite sure what we're going to do with it, but we figured it's nice enough wood to save. So the forms are stripped. Kind of start to see the outline of the new garage. By zoning code dictated we couldn't build any bigger than 2 feet in each direction because of how close we are to the lot line. So it's effectively the same footprint as the old foundation garage. We were able to change the height by 2 feet and the roof pitch to gain some space in the garage. You can kind of see on the right side of this picture that extension cord that's coming out of that pipe in the ground. We actually fed that underground when we built our patio last spring, and ended up using this as our temporary power that's actually plugged into my breaker panel inside the house. We just ran an extension cord through that underground pipe to get out. This eventually becomes the service to the garage, but so we had the pipe in the ground, which is also another reason we decided to push to just go for building the garage this fall, because we had the electrical most of the way there. But a little extra waterproofing of that back wall, kind of excessive, but it makes me feel better keeping the space dry. This is just cool. This is the quarry off of Milwaukee Street. Like it feels like you're out somewhere out west, but the limestone quarry just about a mile from the house, and just thought it was a cool shot because I ended up going there about 5 times with the dump truck to pick up gravel, load after load. We removed a lot of dirt, brought the dirt out, brought gravel back. Here you can see like we put 2 inches of XPS on the foundation wall because with the intention of being able to condition the space, make it comfortable in there. So that wanted to go on first, and then we just brought in lots of gravel, about 6 inches the base, just to make a nice sound base for the concrete. Here's compacting it. You can kind of see it it doesn't seem like it does much, but it makes it quite a bit of difference when you walk on it, and which then helps reduce the settling. We didn't end up putting rebar in the slab, but it's fiber reinforced. So there's like micro mesh nylon fibers in the concrete you'll see later that kind of lock it all together. But again, having a good base is kind of critical. More foam just to keep the walls and the floor a little warmer. Plastic ran up the wall, which has been kind of interesting to watch. There's been some capillary action. I can see in the back wall where water's kind of wicked up slightly under the plastic. But for the most part, it's made a really dry concrete. Another good kind of lesson here is that I learned when you do make a bathtub out of plastic, it makes the concrete set up a lot slower, which we were about to find out. So this is getting ready for concrete day. Another lesson learned: if you want to order concrete, and this was, gosh, early October, you should probably call ahead a good week or two, because everyone wants to try to get their concrete in before the end of the year. So I wasn't able to get the concrete truck until about 3 o'clock that day, which is not a great time to start a pour, because it takes a long time to set up. This was a kind of trick Chris helped guide us with. What you can see Davey and my friend Greg here doing is they're screeing off between two mounds, and those mounds on each side of that 2x4 were shot to an elevation, and we're kind of creating a ridge that we can then scree across. And I'm missing a few photos in here, but you can basically see on the back side of that photo, there's another ridge. Those are shot not level, but planar, because the whole garage floor pitches to the front of the building. So we had that set pretty well, got this mound set and then dragged. You don't see it here. We had a power trowel that dragged across, and now, I mean, the elevation change from the front of the garage here to the back of the garage is about 5 inches. So we're looking pretty good. I mean, this isn't quite a finished surface, but it's pretty much planar to where we wanted it. You can see some of these slight trowel marks, but now it's just sort of time to let it set up. And we didn't quite let it set up long enough, as evidenced by the sticky footprints there. Not what you want to see when you run a power trowel, which is what this device Davey's running. It's basically a giant fan with trowels on it that help work the concrete, cream it, bring the cream to the top, and kind of give a polished surface. Ideally, you want it set up so it's hard enough that you can walk on and power this thing, but obviously you can't do it once it's fully set up. So it's a fine balance, but it was probably pushing 7:30, 8 o'clock at this point, and we'd already, again, stopped pouring, I think, around 5. So it was going to get dark soon, but concrete will do what it wants to do. So realizing, okay, it's looking okay. We're running it, and it's definitely not okay. And it got pretty sloppy. And I remember we were done. Like, the surface was planar. We had pretty much troweled it. We just had to let it wait to trowel, and it just kept getting worse. And so at this point, my wife's freaking out, because she's like, "What the heck? What are we doing?" As you can see, it's starting to get dark. Again, with help some friends, we fixed the dip and troweled it out. It's still not setting up because the concrete's too wet and not drying into the ground like it would normally because of the plastic. And I didn't have any accelerators or anything, because I don't do much concrete. So this is, I don't know, we're pushing 9 o'clock, 10 o'clock. Still kind of working. It's definitely correcting from that power trowel, but it's getting closer. It's starting to set up a little bit. Finally, I think about 10:30, maybe, I was able to get on there with the power trowel, and you can kind of see the swirl pattern like a random orbit sander. It's really starting to mix up the cream and floating it out. And luckily, my neighbors weren't. It was still cold enough. It got cold enough, I think, that night they closed their windows, because that's not a quiet machine to run it after 10 o'clock. Here's a vain attempt to remove the leaves, but as you see later, it was kind of fun. That we got some of them out as we were polishing it. And you can kind of see in the picture the granular. You can really see that fiber. So it's not done yet. It's still too coarse. So this is about the first time when it got. Let's see if this will play. As you can see, I'm not really leaving footprints now as I walk backwards. And it's starting to polish that surface. It's actually a really cool machine when you get it to work, when you get the concrete to work. I was unfortunate that it was getting so late, because I probably would have run it for a few more hours, but that photo might have been about 11, 12 o'clock. So we're kind of pushing the boundary of like making noise in the neighborhood. So we decided about 1:30 in the morning to get out the hand trowels, and we just polished the thing by hand, finished it off to get it smooth. So it came out okay. It's about 2 o'clock in the morning. Sealed the next day. This was sort of the fun surprise that next day too. Those walnut leaves that were falling into the concrete that got mushed into the. So we have a good dozen or two of these fossilized leaves in the, and it's kind of fun because I can see more of them emerging that were coated with cement that looks like it was polished, but as you walk over it, so more are coming out. But another fun one. With 20-foot by 20-foot slab, we had to cut some relief joints, and I kind of waited a little too long, and I killed my first grinder, and second grinder worked okay. It was a joke to use the dust shroud, but had to try. But these relief joints will help it, focus the stress, so minimize cracking, which hasn't. So we got to framing it. We got the back wall up, and we immediately wanted to see the roof pitch, so that we just threw up a 2x4 to kind of get a sense of the space, because we're getting excited to get this thing dried in and get the leaves out of the slab. Yeah, just walls at a time. This is just a shot because I had to put this beam up by myself, and so just one end at a time, cradle it. This was the easy one to get up, even if it's just by myself. So before we started building the roof, we wanted to make it safe, and you can see these two big beams down the middle became a temporary scaffolding. One of the beams actually stays as part of a future loft, but so we spent a day just building this, basically site-built scaffold so we could have a safe hallway up there to work, because we did have to raise this 14-inch by 22-foot beam in two sections. So chain hoist up to the header there, and once I got it up into the catwalk, tied a come along to it, so that we could then drag it into place, and then tied a come along to the come along so we could actually pull the thing up into the catwalk. So it was actually a fairly simple process. We ended up wanting to put a ridge beam in because we tried to maximize the space in there, because we were limited by our site and couldn't build bigger than what zoning required. So the ridge beam allowed us to eliminate the collar ties, which are what would normally go across the side to side of your, tying the walls together. So it's transferring all the load from the rafters through that beam down to the ground, which ultimately gives you a cathedral ceiling, which means you have a full height loft. So it's a little excessive, but it's making for a nice space. That was just to show because that dormer we put on the side you'll see in a minute, we had to meet the roof pitches, and so it's a 512 pitch on the lower rafter there, and that strange looking triangle is just there to marry the two pitches together, as you see in the next. Maybe not the next one. Shingles. This was interesting lesson in how you weave a valley together and in the hip and tie the shingles together. A lot of this type of work is hidden. You don't really see how many layers and ways that things have to fold together in order to make them kind of interact. Just a shot of the ridge vent, because we are insulating the roof. We wanted to make sure the shingles breathe and the roof breathes, and so there's a 1.5-inch airspace underneath the shingles, and this vent assembly allows that to breathe out the top. A little more help from the neighbor's chicken that day. They, I think, were quite interested in what we were doing to their space. Trying to save some money. This is just epoxying the old door that was there. Couple $100 door, so it was worth giving it a new life. Same with the garage door. As soon as we had it closed in, we had to keep closing it in, because now we're getting into, I think it's November, late October now. It's getting cold. So we threw the doors back in here, put a coat of paint on them, and they look pretty brand new. So you can kind of start to see the space on the inside come together. This is basically the first round of framing this garage. What we ended up, so what you're seeing is the substructure that's holding the building together, but we wanted to add more insulation. So what we built next is what's called a Larson truss. Oh, by the way, you don't have, it depends on the products, but you don't have to advertise for Tyvek if you don't want to. It's okay to put it on backwards. So since I knew I was going to be looking at this all winter, I didn't want to read somebody else's advertising. So, and actually, I kind of like the look of the white box. But so our next step was to build a second garage inside the first garage, which is this assembly is called a Larson truss, developed by this Canadian guy back in the 80s who figured out a way, or just thought through a way to use another layer of wood. And what you're seeing here are 2x2s that are basically stapled on to the bottom of the rafters. And we did the same thing for the walls. So what effectively took a 7.5-inch space now became a 14-inch to 12-inch deep space. To give us more insulation, also importantly provides a thermal break between the inside and the outside of the building, so that there's not conduction of energy through the framing. Wood's like R1 per inch, but we're the cellulose that we ended up dense packing here is more like R3.5. So it's a pretty significant difference. And you can't, again, it's just a garage, but we're kind of building nerds, so we wanted to make it as tight as we could. So more kind of see our wall assemblies got thick there too, which is why the windows are so deep. Again, the idea is that you're trying to in a super insulated design, you try to put your pencil on the page and never let it leave the page. And in terms of connecting your thermal boundary and your air barrier. So in this case, by having all these spaces and spread apart interior and exterior framing, we really had a continuous layer of insulation pretty much throughout the building. Again, using a laser to straighten these, because 2x2s aren't very strong by themselves, but once those gussets get nailed off, it's fairly stiff. It was just a nice night. So this is that, you saw that ridge vent before. This is what's called a proper vent, or basically it's providing a chute to connect the soffit to the ridge. And we ended up had some scrap Typar, which is kind of a type of house wrap. And you can't quite see it in here, but there's a plywood rips that are down the side of this that we stapled to this building fabric. It's kind of like almost like landscape fabric with a little bit of waterproofing. Stapled that across as tight as we could to provide, there's about 1.5 inch airspace above that. So basically it's connecting our soffit to the ridge, so that when the heat in the summer radiates down through the shingles, it hits that airspace and vents off. Any ambient moisture in the building that got through your vapor barrier, if it goes up through your insulation, it again will hit that space and vent off without kind of rotting on your sheeting. So not completely necessary, but because we're using fluffy insulation, in this case cellulose, you don't want moisture can breathe through it, and you want it to have a place to go. Less critical on a wall assembly, but on a roof, unless you're doing something like spray foam, you want to ventilate it. So just another process, a lot of processes. And again, we're only working on this on the weekends pretty much. And so it's 2 days chunks at a time. We had the shingles on about 2.5 months after we tore down the garage, but the last 3.5 months have been just getting finishes. And I'm just starting to, about another week, I'll be able to move back in. But here's just a fun one. When we poured this slab on the left is obviously the new garage slab with a compacted base, brand new. This is a month after we poured this concrete. It's gotten cold and the moisture in the grounds froze. And my original garage approach is, just poured gravel, no gravel, right on top of the dirt. And so the moisture has nowhere to go. And as that first deep freeze we had popped that up about 3/4 inch, pretty much consistently along the whole front. And so you can kind of see there's an expansion joint in there. This is just a great example of why you want that expansion. You don't want to lock dissimilar, things together, even though they're both concrete. Our new concrete's a lot more stable than this old concrete, basically because of the base that it's on, and it's dry, it's not getting wet as this old. But so I'm not sure exactly what I do. I'm going to see how it happens in a couple months when it thaws out, and if it'll settle back down or, relief cut it. We're not really planning on using the garage to drive in, but might be a trip hazard. This is called InsoWeb, which again is sort of a different type of building material, like a landscape fabric. It's super strong, like, fiber that's spun that allows air to breathe through, but it holds your insulation in. We didn't end up using that Sector because Chris wanted to use metal studs, and it's hard to staple the stuff to metal. And we had actually thought about using magnets and other things, but ended up doing a different approach insulating Chris's building. But this is often done for dense packing cellulose where you have an open cavity. So what we do is you stretch this across as tight as possible, and you come through. Missed the slide here. Anyways, missing a slide, but you come through and you staple to the face of the stud, and then you come and side stitch, which means you're putting, I think we've got about 5,000-6,000 staples in this garage just to hold the fabric up. Again, another just process to, but once that, the purpose of this is to, when you start blowing the insulation, you don't have, it keeps it tight so it doesn't bulge out past the face of the studs. So there's a reason why people think fiberglass is a good thing. It's because it's user friendly in some ways, even though it's horrible to work with. Not to say cellulose is not a cakewalk either. It has its own issues, dust, but it's a far superior insulation, even though it takes a little more time, technicals. I don't know if this will work on here, but we have a 360 camera at work. I thought I'd just show how, and the resolution on this particular shot isn't great, but it's been a super fun tool for work. Far more valuable than a photograph or a video even, because I can take one, this is one photograph. And you can really see, you can capture so much that you would never, it's always that one photograph, that one angle you didn't get. And so we've been using this for documenting work lately, and it's just been awesome. It's like a $400 camera. It's just 2 fisheye lenses on either side. And it's been it's a great way to make sure, okay, did I lose anything in the wall? If we get done, like, oh, there should be an outlet there. But it looks kind of weird if you don't have the right viewer, which basically it's a multiple panoramic. So $600 in insulation got delivered. And thank you, Scott, for the use of your amazing, oh, there's the sides. So that's side stitching, basically stapling to the side of the fabric. Scott's wonderful, brutal beast of a machine here. Works great. Has so this is Christy's outside kind of showing her setup. This was about a good day and a half worth of work to insulate the garage with this. Figured out a few things to dial in, but basically had her set up in the truck outside, feeding bales of cellulose into the blower, grinds it up like meat grinder, and then pushes it through. And then I was inside, losing, yeah, I mean, it was a long day. I got most of it in the wall. I mean, you can see it on the pile on the ground there. Definitely filled up a few trash bags to bring into the house and throw in the attic. But so the process is just you shove the tube down the wall and you turn the machine on and drag the tube back out. And it slowly fills up the cavity. So all said, we got about 100 bags of cellulose in the garage. And now you can kind of start to see the thickness and the depth of the windows. One of the interesting things about super insulating a space is that it's an audible sensation. Like you feel that you can hear that the space is different. Like I can run a table saw in the garage right now, and you can stand outside the garage and barely hear it. You walk in front of the garage door, you can hear it again, and because the garage door is maybe 2-inch thick, insulation. So these walls are about 10 inches thick. The ceiling's 14 to 12 inches because it's on a slope. Yeah, it's got most of it in the walls. So here's all that wood we decided to save. I kind of opened my big mouth one night and said, wouldn't it be interesting if we ripped that stuff down and put it up as a ceiling? And my wife immediately fell in love with it and couldn't believe that I suggested it. And I really kicked myself in some ways because it turned into about 3 weekends of, I shouldn't say 3, probably 2 weekends of just ripping through nail infested 2x4s. Went through about 3 table saw blades, face shield, the whole 9 yards, and it worked out. And then we had this random mix of like, well, what do we do? We have some dark studs, we have some hemlock, there's fir, there's Doug fir in there, there's white pine, old plywood, a few new plywoods. So it's all basically pretty much everything that came out of the garage. We did buy a little extra plywood for the form boards, but some of these are concrete form boards. And so we just made a spreadsheet to figure out and I don't have the other picture of, like, she actually made, well, what proportion of do we have? We obviously had the most light studs. And so then using this pattern and that layout, we started nailing it up, and she would hand me the proper random, but not random sequence of color. And so we had just enough for old stud. Every stud we got about 4 sticks out of, because we ripped every stud down to 1.5 by 3/4 to make the pattern. Eventually, we have an arched window in the house, so this is just full of trash bags for the cellulose right now. But this is eventually we'll have an arched window. I'm probably going to CNC out on Chris's big CNC, and then put a piece of insulated glass in there. But that's maybe next year's project. On the right side of this picture, you can kind of see what that original beam was that we had for the catwalk. Ultimately turns into this loft area that's going to just be dead storage. Because really the goal of this space is to make this side of the garage kind of our workshop area, and underneath the loft where I'm standing is going to be more for garden stuff and maybe park a car. But not a great shot, but you can see where my level is on that ledge. We had to bump this wall out in the bottom because of that blowout we had in the concrete. So it's like that one mistake that happened 3 months ago is now coming to fruition of like, okay, well, now this wall gets bumped out. But the wall had to be a little bit thicker anyways, because it was how tall it was. But so kind of the final, I spent all that time detailing the insulation and thinking about the vapor barrier. And well, so we did put a heater in. This is like a 5,000 watt heater. And the very first time I turned it on after we insulated, and it was maybe 30 degrees outside, hit 70 degrees inside within an hour, which is pretty good, turnaround considering the delta. But I spent, probably honestly as much time as it took me to frame the building to figure out the damn code for this data logger. But this is just an Arduino with a data logging shield, kind of a knockoff Adafruit. It's got an SD card, real-time clock, and a little coin cell, and fairly simple programming if you knew how to program Arduino. But 3 weekends later, I had this thing running, and my first go at it, I kept it at its original 1 data point per, I think, millisecond, which is a lot of data. I think I had, like, after the first day, I had 10,000 data points, and it was the curve was, it was a little bit kind of thick graph. So I spread it out to 1 per minute, which I realized also might be a lot of data to pick. But ultimately, I ran this thing for the last about 10 days, which gave me this. And I really wanted to get this going while we still had this deep freeze, because back in, it was when I started this on the 18th of February, it was about 26 degrees outside, and it had been cold for a while, and it had been cold in the garage. So the garage, interior temperature garage, when I first turned this on, it started actually about 37. So again, I hadn't put any heat into the garage probably for 4 or 5 days, because I'm not out there that often. So the garage was, in theory, should have been closer to ambient outside temperature, but it was still holding at about 30, 35. This too was my hours that I had turned the heater on that first day, just to see, okay, going from, it was 35-ish, 38-ish inside. It took 2 hours to get it to 62 degrees. And then it's fun to watch it drop, right? And then these red dots are my, outside maximum temperature. The blue dots were the minimum temperature outside. And so you can see, like, even with that dramatic drop, I mean, I don't know the term for that kind of logarithmic curve, but it's it definitely, it drops the fastest in the first 10 minutes. And then the next, it takes as long to drop what it dropped in the first 10 minutes as it is in the next hour or two. And that just kind of keeps going until it met this kind of interesting curve. I don't know what the spikes in the data are necessarily. I think I need to do more testing with this, because I just pulled this last night, but I definitely think I'm seeing potentially sun radiation. I don't have a great south exposure, but I'm thinking I'm gaining some thermal gain. It could be the fact that the mass inside is still radiating off, but why it's not just leveling off is kind of interesting for more. So after that first couple days, this was like on a Thursday night, I got out to there first thing on a Saturday morning to work, and I just cranked it. So 5,000 watts, and I got to do more math the next time to figure out, how many BTUs I was actually producing, and in terms of the gain here. But just steady climb. I hit, and so the other piece of information is that I set this thermostat up about 8 feet off the ground, which is also really fascinating. I want to set up a number of thermostats at different heights in the garage, because at 2 feet off the ground, when I was at 85 degrees, I bet it was only, at this point it was like 60 degrees down there. But even so, I'm finding an average of like 10 degrees per 3-4 feet when I play with just moving it up and down. So a lot of geeky studying to do here yet. But what's really I found fascinating about this next sort of set of days is like I cranked it up that first day. Not sure what the spike is after that, but then if you look at that correlation between the maximum daily outside temperature on those red dots, basically the inside of that building rode the max temperatures. And then as you can see, obviously it dropped down to the 20s that week, but the inside of the building maintained its heat. What I don't know is, like, if you took a regular just garage with some doors and windows in it, how that would hold. I mean, I'm certain this garage would fare better, but that was a fun kind of correlation to see when I actually I would have had a second data logger going, but after many hours of troubleshooting, I realized I think the problem why my second data logger wasn't working is because the solder joint was bad. And that's something, so it was a hardware problem, even though I finally figured out the software problem. So this is just historical data I pulled from. And then the back end here is this last weekend, I just kind of cranked it up and down. There's another interesting correlation about how long it takes to reach a certain temperature, given what you start at. And obviously the delta of, what the outside temperature is. So I think this is fascinating, and there's a lot more I can dig into it for no reason other than I just put a bunch of insulation in the garage to see what it's doing. So that's it. Any questions?
If you were going to bill a client, how much is this thing worth? Not the programming time. You can't bill that. Just the garage. Just the garage. Oh, not the data logger? Oh, the data logger, that'd be like 10 grand for the data logger. How much time I put into that. Geez. I mean, the materials alone were, pushing 15, 20 grand, and we're not done yet. We still have to side it. And that's like saving the garage door. That's saving the ceiling. Like, the ceiling alone, recycling that wood was $400 that we saved. So, but like ballpark, if a client called up, I don't know I guess what I'm really curious is, what does a garage cost in Madison? Like ballpark. If you hired someone to build this garage for you with some of the specifications that we did, you didn't have to put insulation in it, but if you did, 80 grand. I mean, we've built garages before that are over 100 grand that weren't insulated. So it's like, but just the cost of materials is a third of that or a fourth of that. Materials were particularly high this fall, which is unfortunate, but our alternative was letting the garage fall down on its own, which would have happened sooner or later. The snow load this winter might have got it. Who knows? It might have, yeah. But anybody else have other questions?
I want to talk about your data for a second. If I remember right, this data logger is screwed to the beam for the loft, right?
Right.
That beam for that loft points right at your south-facing windows.
No, other side of the beam.
Well, sure, but the beam itself.
Oh, sure. Yeah.
So I'd be curious to like stand that thing off and I don't know, put some insulation between the wood and the data logger to isolate into like your cavity airspace temperature and not the beam temperature.
Well, the beam is high enough; it doesn't get any direct south light. You know, the way when the so it is theoretically trapping heat in that because it's underneath the loft, but I don't think there's enough convection in there to make a big difference. I do want to play around with it. Ideally, you don't put a thermostat on an exterior wall, right? Because then you're going to kind of trick it.
Yeah.
I don't have any interior walls, and I needed to be near power, so it was kind of yeah. So it's not so these not like so for example, like at the when I cranked it up for that 6.5 hours that second day, it was at 85, 87 degrees at 8 feet off the ground. Okay. Whereas like at human height, where thermostats usually 5 feet off the ground, that if I remember right, I was pushing like 72, 73 degrees. So all of these spikes in the temperature, if you just subtract 10 degrees, that's what you would normally expect your ambient room temperature to be at. So like the reason thermostats are at, you know, where they are on the wall is because that's where we feel most comfortable. You know, if you put them way down on the ground, they wouldn't be as accurate, or obviously way on the ceiling, they wouldn't be accurate. But if you look at like the heat map of a convection currents, you know, you can really see that, you know. But yeah, you're right. I need to move it around more.
Well, even if you just put it on the other side of that beam, then you wouldn't get any trapped heat. You would at least get like the natural movement of air, right?
Yeah. But what's interesting is like I'm not necessarily when on these days that I'm watching it cool down, there's no air movement in the garage. And so the spikes in that data you're seeing are, I mean, there might be a little bit of air movement, but it's just radiation through either through the glass or through the thermal mass of the concrete kicking back off. And then it's kicking back off all the time or slowly cooling off again, or all the surfaces are cooling off. But the outside temperature gets much colder. So like the dips that you see in that long middle section of that graph are because I think it's cooling off outside. Why it spikes back up during the day is it's hard to imagine if it's not just solar gain. But.
Well, and there's one thing you got to keep in mind also is for an industrial data logger that has not you know, super minimal errors in data logging, you're into the thousands of dollars, and you paid like $27 for this setup. So yeah, these spikes very well could just be you know, the power rose a little bit, or the whatever, you know, the board whatever hiccuped and it just read wrong.
Yeah, well, the spikes for sure, but the gradual ups and downs I think are probably pretty true to form. And every time I have two other thermostats in there that are hardwired, and I've double checked it to this, and they all three read the same as sort of a.
And I'm only really talking about like your spikes here, the random vertical spikes and stuff.
Yeah, no, I should have. If I knew more about Excel, I could probably smooth those off.
We could take this offline, but I could help you with some algorithms that would help. Like, you know, if this point is totally off from the point before it, then just throw it away, basically.
Right. Yeah. Yeah. Exactly. Yeah.
Looks like Mark's got a question.
It's all wonderful engineering and artisanship and keeping the marriage together. So, what thought went into putting tubes in the floor or not?
So say it again, Mark.
Yeah, Mark, you're very hard to understand.
Putting heating tubes in the floor.
I think he's asking about putting heating in the floor.
Oh, well, so technically, you know, I'm not supposed to heat the building, because I mean, so the garage door is a big thermal loss, right? This is definitely far more insulated than any other garage probably in town. And so I'm not really worried about, I mean, again, with how easy it is to heat. And this is also like, some of this data was taken in the coldest time of year. So like, this is a small snapshot, like come, 2 months from now, I can light a candle in there and probably warm it up. I think it would have been, again, it was trying to keep it as cheap as possible. And it's still not a cheap endeavor to build, space like this. It would have been cool, but I would have had to have a full foundation in order to put in a permanent heating source like that. And then a boiler and the PEX to run it. I mean, I would have added a few $1,000s versus my little heater was about $250 on sale at Farm and Fleet. And if it lasts, you know, a good couple years, it's probably going to be all we need. I do want to look into automating like because it's 50 feet from my house, right? So like I have to walk through the cold to get to it. It would be, at some point I might look into like connecting that heater to some sort of app where I can turn on the heat before I go out there half an hour. But really it's quite comfortable after half an hour, you know, maybe you're in your t-shirt within an hour working out there. And then it holds the heat fairly well. Again, we kept out the telling ourselves it's a garage. It's not a, you know, it's not a house. It's a little house, but.
Anybody else have any other questions?
One more point that I want to make is when you fill your garage with all your crap, make a note in your data log permanent record, because I'm curious what the thermal mass of like all your bits and bobs is going to do to the temperature change in your building.
I think it's going to take longer to heat up, but it's going to stay warm longer.
Right.
Right. It's just more thermal mass to heat up.
The instantaneous spike will be faster, but you can kind of see how your spike like shoots to the moon. And then as it settles off with a differential. That differential is the actual heating of the objects in the building and the thermal mass. And the spike is the air mass. So that's why the spike drops so rapidly, is you're just allowing the air to go back to ambient or go back to whatever the thermal mass is in the system. So you're seeing that huge spike because that's the air temp, and then the actual delta in steady state temp is the wall cavity surface, you know what I mean? Like the actual mass inside. So as you add more crap, the spike will actually be faster, but then the delta will take longer to kind of establish between the two steady state temperatures.
That makes sense. There's less air to heat up.
Yep, because your air will heat really fast, and because there's less of it, but then your mass, as your mass heats up, it'll stay hotter longer once it gets hot. Cool. Well, thank you, Sean, for sharing everything. John, did you want to go next, or?
Sure. Can you hear me?
Yeah.
All right. So well, my cat's going to come join us here too. I just wanted to share a little bit of this experience. I just learned a bunch of stuff that was interesting to me. It might be kind of obvious to some people here, or maybe not interesting, but I had a friend ask me, he said, "You're an app developer. I have this idea. I'm writing this book. It's going to be 42 chapters. I want to make an app with a shape that has 42 sides and a chapter on each side." So I thought this was a really cool idea. And I was like, he asked me how much he would have to pay someone to do it. So I thought, well, I should find out what it takes to do it, at least, superficially, but I got really into it. My first question was, what is a kind of regular-ish 42-sided polygon? And I really didn't have any idea how to approach this. I was kind of a math person, but it's been a long time. So here, I'm going to share. But I found so many resources online. It was really cool. All kinds of people sharing these shapes. It just so happens that one of these is regular. Obviously, you can create an irregular 42-sided shape of any kind, but he wanted it to look more like, a soccer ball or something. So this turned out to be really easy. Not only did I find these definitions, but I found formulas, and I found even people just have these printouts of all of the data that you need, all the vertices and all the everything that you need to create one of these things. So I actually didn't know what you needed to create one of these things. So here's the code that I wrote. I have a few different iterations, but I started out with just downloaded a bunch of vectors that represented the vertices. There's 42 of these vectors here. No, there's more than 42 vertices. There's a lot more than 42. But I actually found a tutorial that told you how to build a 3D cube with an iOS library called Metal, which kind of talks right to the GPU. So I just figured out, I followed a tutorial and I plugged a bunch of all the numbers that they had in a big list into this thing. It was a pretty brute force thing. These are the indices, which tell you It's a list of the vertices by index that create all the different triangles. So each one of these sets of indices is a triangle surface. And then the other part of this is the surface normals, where you have a vector that corresponds to the vector that's perpendicular to each face, so that the graphics processor knows what to point on the outside. So anyway, I ended up with this kind of coded, and I'm pulling up my iPad here, if this is going to work. And I'm going to share. Well, it's a little bit kind of jumping the gun to share what I actually got it to look like, because it took me a little longer than that, but I'll do it anyway. First, I'll stop sharing my screen, and then I will start sharing my iPad. Yeah. Oh yeah, this is totally jumping the gun, actually, because the hardest part was getting these surfaces. But I could get this thing, and I had to add kind of manually the vector transformations to, I'm rotating it with my finger. You just have to take my word for it. Pinching in, oops, yeah, pinching in, pinching out, rotating, all these things. It turns out what was really, really hard was to put text on here. And I don't know if people know about this, but when you're working in 3D graphics, you map all of your triangles onto a 2D surface, and then you feed the graphics processor a map that points, it's a UV map, that's what they call it. This is all stuff that I just kind of learned on the fly here, but it maps the surface in the 3D model to some section of a bitmap file. So I'm going to share my laptop screen again. So this was really, really hard. And the really hard, so I got some stuff imported into Blender. Here's all the different triangles. I got this map. This was my UV map here, which is kind of like a nightmare. And I improved this. Let me open my other one. Oops, my Zoom window is right over that. I improved this a bit, where I was able to represent these as hexagons and pentagons, because it's a mix between hexagons and pentagons here. And get this. This seemed great. I loaded some images in there. I put it into a graphics file. I put some just random stuff that I could identify. I put some text. But the problem with this is this is actually a very high resolution file in, like, it's a gigantic bitmap file, but it's huge, and it takes forever to load into the GPU renderer. So this was totally not possible, and in fact, I got this stuff in there, and when you zoomed in, it wasn't really legible. It certainly wasn't smooth or anything you would want to kind of look at. This is a little bit of a standing problem for me, is that what I want is some vector graphics here that are infinitely zoomable. And I'm not quite sure how to tell the metal library, how to do that. I did find a way in Xcode. There's this library called Scene Kit that actually made everything a lot easier. You define a scene, you can tell it in a really simple way that you want cameras and how much light source, where you want the light sources to be, where you want the cameras to be. And with that, I was able to create, let's see, what is it? I put my face on it at some point, but then I took that off. Yeah, okay, yeah, see, these are my gigantic files that, oops, I clicked on the wrong one, that make the thing spin like crazy. But I was able to create an iOS text label, just load text into it and just plop it onto this surface. And that's what ended you up with what you saw before. And that's like, okay, but I want there to be a lot of text on there. I want the text to kind of fit to the contours of the hexagon and pentagon. Ideally, and in talking to the author, he had the idea that maybe we could have fragments of text, because it's supposed to be kind of a random access text anyhow. So I thought that was kind of an interesting idea, but then he's talking about animating it, which I think is going to be way harder than just squeezing all of this vector graphics onto the text. I don't know if anybody's heard, I watched a talk, this guy that wrote a library called Glyphy, which is a vector graphics library to render fonts, basically render fonts and smooth fonts, and then be able to do transforms on them. But it's all written in C++, and I can kind of read C++. I don't really know how to get it from his library into the graphics processing unit on an Android phone or on an iOS phone. But I totally went off of my notes. I've just been jamming here. In Blender, I'm sure there's a way in Blender to create a UV map for each face, like kind of separate the faces and have just a high res image for each. I still think that would be clunky, but I never quite figured out how to do that in Blender. I totally don't know how to use Blender. I'm just hacking away at all this stuff. One little interesting problem was that everything got reversed when I put the bitmap into SceneKit. I wasn't really sure why that was, but I was able to just take my vector file and just flip it and then save it and then load it in. So it all wasn't so bad. But anyway, I'm gonna share the iPad just a little bit, just let you stare at that a little bit more. But that's kind of where I am, and I'm not really sure exactly where we're gonna go with this, what's next. He seems pretty happy with what he's seen. Obviously the lighting could be a lot better. Be nice to have something in the background, but I can get in pretty close with this without it getting too crazy. Yeah, actually that's really nice now that I'm looking at it. So that's the project. I just thought it might be of interest. I thought it was a really interesting journey for me, and I don't know, maybe if there was anybody, I thought this was a good place to find maybe somebody that would look at this and say, obviously you're doing something very, very wrong. You should do this and it's way easier. I'm totally open to any of that. Or if you know somebody that like maybe would have a clue for me or anything like that. It's obviously it's a pet project for me. It's a friend, but he does have like a book contract for this novel and he wants to release this app as part of it. So it's kind of a real project in that sense. And I think that's pretty much, now my cat's sitting on the trackpad of my other computer, so I can't look at the rest of my notes. But I think that's pretty much all I had to say about that. So that's all.
Hey John, this is Dennis. This is kind of related to some stuff that I do. So I'm going to throw a few ideas your way, but try not to take too much time up in the meeting, but we can email about it later. So one of them is level of detail. So when you're zoomed out on the sphere, or I'll call it a sphere, the thing here.
We call it the polyhedron.
The polyhedron, your textures don't need to be very high res.
Right.
And then when you zoom into the one of interest, you can swap it out with a higher res texture. So that's one thing. The other thing is when you zoom in, you can see the texture gets a little soft. There's a really cool technique when your goal is sharp edges, which is that you store something else in the texture called a sign distance field. And then you have a shader that when it does a lookup, does a threshold based on that. So you end up with really sharp edges on your
This is exactly what Glyphy is. It's a sign distance field. Yeah, exactly. So I know that term. I just don't know how to do it. That's really cool. Sorry, I don't mean to interrupt you.
Dig up some resources. Glyphy itself, I think, is open source, so you could dig in and see what it does. But given either super high res image or a vector thing, you can generate this sign distance field, and then there's a pretty simple shader that'll create your sharp edges for you.
That's awesome. Thank you so much.
Yeah, cool project.
So just generally speaking, you want this to run on an Android and an iPhone device is the kind of the goal?
I think ideally it would also go, yeah, I'd also write an Android version of it, yeah.
And is it to live in its own app or what is it? What do you want to do with it eventually?
Just this, like what you saw, but yeah, so yeah. It's more like a promotional thing for this novel that's like, that somebody spent a lot of time writing.
You actually want to be able to zoom into one of these faces and read the whole chapter?
That was my original idea. I think that would be kind of cool.
You could certainly make it where you zoom in and it can, it can be rotating as you go so that all the text is correct reading. And then when you've zoomed in far enough, you've actually switched into a different view that's just
like a flat reading.
Just a text renderer at that point. And then when you pinch back out, it cross fades into this, and the whole thing could be seamless, so you don't even realize it.
That's very cool.
A fun experience.
Yeah, I was heading in one of two directions. One would be you could almost fake this with Prezi. I don't know if you get the animation, like the play with the ball thing, but like I guess what I was envisioning was what Dennis just said, which is like a Prezi type transition between a reading mode and a 3D rendered mode would seem like it would solve your rendering a giant image file on a surface.
Yep.
And the other thing I was looking at, which is the reason for asking like how you want it to behave and run, I was Googling in Unity to see if Unity was something that would be an appropriate choice, but it doesn't see. Unity's got all the 3D advantage, but I don't know that it's going to help you at all in the text world.
Yeah, Unity is something I've worked with, but yeah, I don't think that's, it's definitely not like a very common use case to like zoom way in on something and kind of be able to read it.
Anybody got any other questions or suggestions for John?
I wonder if instead of having one giant texture map for the whole thing, if you actually split this up into all of its faces, then you could assign one image to each face. And then you'd also have a little more control about which ones were high res and level of detail and so on.
That was definitely something I was trying to do and just couldn't quite figure out how to do. One of the reasons is that the, you know what, if I was better at Blender, I bet I could do that. I bet I could export those UV maps one at a time for each face and assign them to the faces. But I couldn't make that happen, and I kind of gave up on it. But
what if each face was its own object and they just were oriented precisely the same way?
Right, that's right. So yeah. I still don't know how to do it.
Well,
but I think
what you have done is super impressive. So it's, kudos to you.
Thank you.
Yeah, throwing yourself at the wall and getting a thing that you can play with on the iPad is pretty awesome. I'm still waiting for Shira to come in with like all the Blender foo all figured out, but I'm not hearing it.
I just rely very heavily on the internet. The Blender community is pretty good about answering these questions, and there's this one I don't know if it's a channel or it's a Redditor. It's some like entity who posts these things to the Blender subreddit called Blender Secrets. And it's a little hard to search for like the secret you want today because there's about 500,000 secrets, but they're incredible. They're almost just fun to subscribe to, just like, they're like 30-second GIFs, and you can just like learn how to do what you're trying to do instead of like 3 hours and like 15 seconds.
If you
also,
can find
John,
the right
when your friend decides that this book has 43 chapters, this person is no longer your friend.
Yeah, that's when the shape gets clever, right? As you're spinning it, it's replacing the tiles, so that you never notice. Like, oh, there's one that kind of morphs in relationships, or strangle your friend. There are two options really for that.
I like your idea. There's less jail time involved.
Yeah, you never know. Trying to get Blender to do anything usually involves jail time because Blender is insane to get anything to have. I've loaded Blender and I've gotten the cube to show up, and I think I put a sphere in and then like moved the sphere around, and that's about as far as I ever got.
Well, they give you the cube for free. Every time I fire up Blender, I have to relearn all the basics because none of them are stickable in my brain compared to a normal program.
And see, there's Dennis to swing in and tear me down. I was trying to make it sound like getting the square was something big here, and Dennis is just, oh, the square's already there. You just had to make
cube.
The
it's called a cube. The joke is every tutorial starts with this: delete the cube. Okay, make another cube.
Well, thanks so much, everybody. Thanks for your ideas. That's really helpful.
Yeah, thank you for sharing. I always try to pick things that alternate in themes, and so I like the world opposite is always my goal. So you've done a wonderful job, John, of taking us from carpentry and like rough construction into like the depths of Blender, which is its own special level of terror. And
geometry was the common theme there.
I'm gonna throw it back to Dennis to bring us back to woodworking. So at least that's what I think.
Oh, am I next?
Yeah, sure. You look too comfortable. I gotta make you uncomfortable, since you're throwing me under the bus there with the cube.
The cube. Let me start a share here. Whoa, where's that window? Go away. Is that Sharon?
We can see a sewing machine on a table.
Yep.
All right.
So my wife's pandemic project is sewing. And so my pandemic projects involve helping with that. And I can't remember if I shared this one before, but I remember going out to the list and asking for advice on this plexiglass table thing and what kind of glue to use to hold the legs on and stuff like that. And I got some great advice from everybody. So thank you very much. And there's the final result. It's kind of hard to see there. This one has a reflection in it, so you can kind of see. It's for when you're working with a really big object, and so it doesn't fall over the edges of the sewing machine there. If I have shared that before, apologies for the repetition.
Kat says it's brilliant.
The sewing machine's got pedals. You can almost see one under the table there, and they randomly scooted around, and the new desk actually has a crossbar. So 1/4-inch hardboard little boxes that slide back and forth on the bar to keep track of the pedals for the 2 different machines works out pretty well. These are just random projects. Storage for rolled up pieces of cork material, and after measuring, and vinyl, cork and vinyl. So after measuring the material, designed up a little shelf with slide in shelfy bits. There it is, full of the material. Keep them all clean and safe. That was kind of a fun one-day project, and managed to not slice off fingers grooving wood without having a table saw. Clipboard holder thing, that was kind of a fun challenge with angles, keeping up with the geometry theme for the evening. Unfortunately, did not make the back section long enough, so when you put the clipboard on, it fell over. So we ended up having to put a foot on the back and a weight under the front in order to counteract all of that. And this was a different project. Chris helped with the lasering. A friend of mine is an avid gamer and has this game called, I think it's called Aeon's End. And he has the original game plus 3 expansion packs, and it just doesn't fit in the original box. You end up carting all of this extra stuff around. So he found these plans online for a box, and I said, oh, I can get that built for you, without realizing how gigantic this thing was. It actually used 2.5 sheets of 2 foot by 4 foot birch. Chris did the lasering on this, and here it is being constructed. I never have enough clamps and things. To save time on the big fancy laser, I have my cheap little diode laser that did the engraving for the cover. And then, oh, sorry, timer gone off. That is the bottom section that all the, I guess, cards go into. I'm not a gamer, so I don't know what they're all called. Then there's this middle section with a sliding cover. Can you take the film off the thing? Am I still live? Oops, where am I? Can you still hear me?
Yep, you're good.
Okay. There is the cover with the engraving on there. The design was pretty good for this. Some of the internal slots were tiny bit too small for the fingers, so I had to sand down a couple of the internal fingers. All the external fingers worked well. The one weird thing is there was 0 tolerance for this cover over the top of the middle guts. And I'm glad I figured that out before I glued together the cover, or it would have never fit. So what I ended up doing is actually gluing together the cover over the guts, but with 2 pieces of cardstock all the way around in order to provide clearance, so that once it dried, it could actually still slide on and off. So I sent that to him, and he sent back pictures of it fully populated with the game. It's all full. And then he said, oh, they just announced the 4th expansion pack, so he's still going to end up carrying around little extra bits. Oh well, that's life. I don't remember if I shared this project going on a couple years ago, but it was the only time I've ever cut anything on that stupid diode laser, which I wouldn't recommend doing. I just use it for engraving now. But you can buy little tiny, USB drives and make your own packaging around them. So when my wife graduated college and wanted something to put her portfolio PDF on for potential clients, we designed this 3D printed tray that holds a laser cut thing with her logo and one of these little tiny USB drives, and ended up replicating, I think, 35 of these that she can give away. So that's my quick project summary of things. Some old, some new.
Should have talked about my bagels.
Any questions? No
Are you
question.
planning to finish the wood with anything like to keep it from getting dust?
I did tell him if he wanted to, spray it with something, it would make it look nicer and, protect it a little bit. I did do a lot of sanding on it, so it has a nice feel to it. You don't have too many rough edges from the construction, from the glue and the laser and things like that. But it's up to him to do any finishing on it.
What did you route that your vinyl storage if you didn't have a table saw? You use your router?
Yeah, a while back I picked up a couple different size router bits for the Dremel and had never had a project to use them on. And one of them, the biggest one actually, the scariest one is the first one I've used, is a 1/4 inch router bit. And so I clamped down a piece of wood to run the router. I have the screw-on thing for the router that provides a little bit of a skirt or a shield that you can push down on and run it against a surface. And so for the most part, they were straight. I did a short one to make sure the 1/4 inch hardboard would fit into it, and it did. The long ones, which I think were 18 inches on 2 sides, when the boards started going in, as they weren't quite straight, the boards would have to conform to that. So one of the boards I did have to hammer in. They're not going to be coming in and out. They're not like shelves that slide, but it all works. For some reason, due to the stresses involved, the whole thing canted a little bit when it dried. So it's definitely not 90 degrees, which is totally embarrassing, but I'll blame it on lack of having the right clamps, I think.
It's hidden in your closet, isn't it?
It is, yeah.
Yes,
But unfortunately, because it's lined up with the door of the closet, like from across the room, when you glance across, it makes it super obvious that that's not straight. I don't even think I noticed it when I brought it upstairs and installed it and everything. I think I was sitting in the room and glanced up and I'm like, oh my God. I'm sure, I could crack all the glue and re-glue it and all of that, but it's a closet, so.
Was that like a Dremel, like a handheld Dremel tool that you used as a router?
Yeah, there's a router bit that you can buy for it, different sizes. And then some other accessory kit that we got, you can unscrew the little circular thing behind the bit, and this thing screws on, and it's like a skirt or a shroud that fits over. And then it also has a screw so that you can adjust the depth. And so that was another thing, was to figure out a good depth to route that would give enough grab for the shelves to not fall out, but not too deep. I also, the first path I tried to route was just too deep for a Dremel to reasonably do, and the bearings in there shift a little bit. And so I tried to go straight, but every time it hit resistance, it would actually pitch out a little bit. And so the line was totally zigzaggy. It took me a while to figure out why it was so zigzaggy. I thought I wasn't holding it against the shield, but it was actually the bearings in the router, I think. When I went for a shallower depth, it was way faster and way straighter. So I ended up taking 2 passes, I think.
Yeah, I was gonna say, even with normal routing, you often do multiple passes, partially for like horsepower of the router and partially for like chip out.
That makes sense.
You may have demonstrated a Dremel that's run for more than like half an hour at a time. So it's got that going for it. I don't know. My youth is filled with just murdering Dremels, like not really doing anything too crazy. So I've
had this Dremel for a really long time. My Dremel and my bandsaw are my favorite 2 tools. And whenever I go to any place where there's a maker speaking, in the Q&A, I always ask what their favorite tools are and make a list. And the one I was missing that everybody kept saying was a drill press. And so last summer I got a drill press, which I have used. I won't say I haven't used it, but the Dremel and the bandsaw are still like the go-to tools. And now the laser, that's kind of fun. But
any other questions from anybody for Dennis? Cool. All right. Thank you for sharing, Dennis. I think I have the last presentation. I'm going to talk a little bit about figuring out some locks and yeah, how to basically go from a lock cylinder into having a key to be able to open a lot of door locks. So we got, I think when we were clearing out the City of Madison building, when we were recovering material that we were using in the building, I'm pretty sure somebody ran around and took like every door handle from every door in the whole goddamn building, because I've got a box full of doorknobs. And then I like found another box the other day and it's full of doorknobs too. We got like there's got to be like a half a pallet of door handles, plus all the door handles that are already in the doors that are upstairs. And so I thought I need to put some door handles on the 2 bathrooms that are upstairs, and we're eventually going to need more door handles and doorknobs for the rooms and stuff that we'll end up building. Maybe it would be a good time to like unlock those door handles and put some new keys in them, some new locks in. And it was interesting to figure that out. I've never rekeyed anything before, and so it was fun to learn. Let's see if I can get this to work. Fun to learn how to make that work. So I think you guys can see my presenter screen, right? Over this way?
Yes, you got a full screen slide.
Perfect. All right. So yeah, essentially I got to figure out how to get our door handles to be usable. And the interesting part was, I don't know, for some reason I thought if you have access to the doorknob, right? Like we're on the back side of the door, so you just disassemble it, that you'd be able to remove the bolts or whatever we're holding the knob in without having to unlock the lock, and therefore you'd be able to get the cylinder out and repin it or rekey it. You can't do that. You have to unlock the door itself. Like the door knob has to unlock to be able to free the handle from it. So if you haven't taken Kevin's lockpicking class, this would be your learner course. If you have, this is your refresher. For Mark, who's taken it 3 times, this is your refresher. And the idea here then is you've got a key and the key slides in, and the cylinder is in the middle of the lock, and this part you normally can't see, and that's the part that's holding all the springs and the other pins. And these pins are all of variable lengths that match up with the variable heights of the key, and so when they're lined up, the cylinder rotates, and when they're not lined up, it doesn't rotate. And so this is kind of the bottom right is the part that you normally see on the lock, which is the part that you're sticking the key in, and those pins are sticking upwards with the springs. So my options were I could drill out the cylinders, and Jim said, why don't you just drill out the cylinders? Or I think he asked me more specifically, what would a locksmith do? And I said, drill out the cylinders. And the issue with that is then I got to buy new cylinders, and new cylinders are like at least $13. And if you buy a $13 lock cylinder, it is like the cheapest, crappiest lock cylinder you can get. And so now you've got a really shitty lock cylinder and a really nice lock, and that lock cylinder is going to bind up and be garbage basically. So you're kind of want to keep all those like old City of Madison parts, because these things were really expensive when they were bought. Like a nice handle set for a lock is like $150. And so I'm definitely not spending $150 on a lock, but if I have a $150 lock, so I might as well keep all the pieces from it. So I could pick the cylinder, and that's the process of raising each pin individually until you can figure out the shear line and unlock it. I am terrible at that. Shira's Scott is very good at that, and I thought about just mailing all of these locks to Shira's house and letting Scott take like 3 seconds to unlock all of them, probably tell me that I'm an idiot and I'm terrible at picking, and these were the simplest locks he's ever done, and then throw them all back in the box and mail them back. But again, that would cost money, and I have to admit that I was not going to be able to figure out how to get these handles undone. So I usually try to rake the cylinders, but I have not played with the locks in a long time, but that's a little less skillful. And I looked around and realized these were regular Schlage lock cylinders, and so we have bump keys. And so the idea of a bump key is you're just putting a key in that's cut all low, so it's just got these little dimples in it, and you just smack it with a plastic hammer, and it makes all the pins fly up in the air. And it's just pure luck. There is no skill at all. You're just, if it's lucky, it'll unlock, and if it's not, it won't. So I took like 20 minutes dicking around with it, and I couldn't get the bump key to work. And so I went over to the bandsaw and I figured, well, you know what? I'm not even sure if I have to unlock this thing to get the handle off, but I can't figure out how to get it apart. I was going to chop the handle off and figure it out. So I chopped the whole knob off the door, and then I took it to the mill. And this bottom left picture, what I did is I just barely skimmed the top off the lock cylinder. And I actually got lucky. I didn't even catch the springs that are in there. So like this was just barely shaved. And then the bottom right, I was able just to peel back the little brass bit on the other side until I could pull out each spring without sending the springs flying. And so by doing that, I was able to remove the pins out of the cylinder, and the pins stack up in what's called bidding. So bidding is this term of the little stack up of all these pins and what allows you to unlock your lock. So once I got the springs out, I could tip over the stack and dump out the pins that are in there. And you can see on this right side, I've got the key bidding specification for Schlag. And so they tell you like what the angle of the key is supposed to be, the distances between all the pins, the heights of the key itself for different pins. And then these down at the bottom right, it tells you which pins to use. And normally on a regular house lock, you have a bottom pin and you have a top pin. And you can see all the top pins, there's only 3 options, but the bottom pin, there's 9 options. And so the combination of 5 different positions plus 9 different options gives you like a huge number of key possibilities. But to be extra annoying, you can also put in these little master pins, which are down to like 10 thousandths of an inch. Actually, they're even smaller than that. Sorry, 30 thousandths of an inch. So you can have these little teeny tiny little wafers in there. And the wafers then stack up to allow multiple keys to unlock a lock. And so that's this idea of like a master key, where you can have one key that unlocks all the locks, but then many keys that unlock individual locks. I have never played with locks before in rekeying them really, let alone having to play with the master keys. But so what it ends up looking like is this disaster. So you've got down here at the bottom, I've got labeled, there's 6 different trays. And I dumped out the contents of each one of the cylinder locations. And of course, a regular house lock, like I said earlier, is 5 pins. The city, of course, buys 6-pin locks. So they have an extra cylinder spot in the lock, which of course means you have to pick 6 different pins. Now, when I was bumping these, I had suspected there might be 6 pins in it. So I was using a 6-pin, it's called SC4 key, and trying to bump it, I could not unlock it. And so I was like, well, maybe it's a 5-pin. So I brought my 5-pin lock out, or my key out, and I bumped it with that, and that was how I was finally able to unlock it. And I realized that the nose of the 5-pin key is actually just barely hitting that 6th pin and knocking it up. But the 6-pin bump key is actually lifting it up too high, and it was binding all the time. That's why I was never able to get it unlocked. So long story short, I dumped out the contents of the first lock cylinder that I milled apart. The second one I got unlocked and dumped those contents out. And now I had 2 locks to compare between. And this is just an animation so you can understand what the shear line is. Again, if you haven't looked at locks before, the green things are the master pins, the red things are the bottom pins, and the purple things are the top pins. The top pins never interact with the lock. Your key is just interacting. The top pins are like what the spring pushes on. So those things don't have any effect, aside from they do vary in length occasionally to allow for more or less master pins. Because at some point you'll stack up too many pins and you'll bind the lock itself. So you have to make a shorter top pin. But anyway, so there's multiple keys that can fit and unlock this lock the way that this one's configured, which is the same way that the locks that I was taking apart was configured. So I got out Excel, which now that I know Sean's an Excel expert, I'm going to call him next time. I got to sort out Excel for me. There are no plots or graphs, just this boring data. And what I did is I took each key. So we have key 1, key 2, and key 3. Oops, sorry, key 1 again. It's supposed to be key 3. You can see on here I've got a confidence. So high confidence means I milled the top off of it. I individually lifted the pins. So I know for sure the stack up order and where they came from. The second key I took apart, I kind of like slid it out a little bit fast. And so it just like shot pieces all over the place. And I didn't realize how many master pins were in this one. There's more master pins in this one than there were in one of the other ones. And so I didn't realize to be looking for them. And so I missed a few of them. So my low confidence is like, I'm not really sure if the master pin came out of pin spot 3 or pin spot 5. And so I kind of just guessed. And which is why I took apart and bumped a third lock, was to take apart a third one and figure out where these things all matched up. So long story short, we stack up the pins by measuring the height. So column 1 is the height that I measured. The pin number then is the corrected measurement. So this is 0.222. and it was actually supposed to be 0.225 to match up with the Schlag system. And you'll see where the pins actually vary in length. I'm guessing it's machining or manufacturing tolerance where they're like close to within a couple thousandths, because some of them line up perfect and others don't. It might be too literally wear, where they're just literally wearing down, because I never saw any that were long, just ones that were shorter. So then at the very bottom, which is the important part, I lined up possible keys. So for this first pin, or the first row, their only possibility is a key position of number 4, because there's only a 4 bottom pin in every single lock cylinder in the front position. Then for pin number 2, I could have a 1, or I could have a 1 plus a 6, which is the master pin is a 6. Then for position 3, I could have a 2 plus a 4, a 2 plus a 2. So you're kind of picking like a lowest common denominator. So I wanted to make a key that would unlock all of my locks. And so I wanted to pick the lowest common denominator in all these. And so as a locksmith, you can have a high key, you can have a low key, or you can have a random master key. I was lucky that they picked a low master key. So the key is cut to match all the bottom pins. And so all I had to do was cut a 4, 1, 2, 5, 0, 7 key cut, and I would be able to unlock every single one of my doorknobs. Easy enough, right? You just go and cut out a new key. So the problem that I ran into then is I didn't have any SC4 key blanks. So I literally just couldn't go to we do have a key cutter, so I could have cut a new key, but I didn't have any blanks to cut from. And so I actually was paused for a second, was like, all right, well, I'll just wait till I get key blanks. And then I realized, no, I don't need to do that. I could just go on Thingiverse and I could just print the damn key and unlock whatever door I want to unlock with it. And if you've never seen this, you can print a key just from OpenSCAD. You just put in a key combination and it'll work. The annoyance is everybody on Earth has 5-pin locks. And so I had to go in and use some code foo to add in the 6th position pin on this key set to make a 6-pin lock. But that turned out to not be too bad. So at the left side is my key that I printed. At the right side is my lock cylinder that I reloaded with only the lower pins. So I wanted to verify this key would put my lower pins in the right spot. So I put it in and the shear line was all low. So it wouldn't have worked. It wouldn't have unlocked because all the top pins would have still bound. So I went back and looked at the code and the guy put in a 0.5 millimeter fudge factor. So apparently his printer wasn't printing well. And so he just fudged it a 0.5 millimeter to fix it. And so I removed the fudge factor and then the key worked just like it's supposed to. The only other thing I had to do is some of these doorknobs I don't think have been turned in like 20, 30 years because they were the hardest doors. Like I realized too why I was having so much trouble bumping the first lock is it was super stiff. You normally have to put like mild tension on. I had to like practically twist it with a wrench. And so I cut the whole bottom of my 3D printed key off and stuck in a metal tension wrench to be able to twist it hard enough to get the doorknob free. Then once the door, you can see how dirty the inside of the cylinder is. Once the doorknob's free, you can see the key is indeed lining up that shear line, which is why the door lock unlocked. And then this little plug is a plug follower that you push in to keep all the springs from shooting out. Because if you don't do that, these springs that are in here will launch all of your pins out. And so the trouble I was having when I was disassembling the first 2 locks was that as you remove this, you have to capture all the pins that fly out. And if you don't, then you don't know what the pinning was anymore. And if there's more than one master pin in there, then you don't know what the stacking order was. So like it's kind of a pain to get them out. The long story short, though, is I was able to go upstairs on one of the doors that was stacked up and stick the key in the door lock, and it actually unlocked the door. So I now have a master key to unlock all of the City of Madison door locks that we have. And so that was the goal, was to make it so that I didn't have to pick all of the keys in the whole building. I could just unlock them. And yes, Shira, that is correct. And yes, Scott. Assuming the city did not rekey their doors, we would have a master key for all of the door locks for all of the buildings. The interesting thing is we have that really nice Milwaukee cordless bandsaw. And people do this because there's nothing to prevent someone from going in a building if it's accessible and just cutting off the doorknob. And then take the doorknob home, you can unpin it, and then you can make your own master key. So if like anybody literally went into some huge building and chopped the doorknob off and went home with it, you could just make your own master for any building anywhere if they used a master keying system, which is why so many buildings now have digital locks. But you'll notice that all of the digital locks always have a physical key lock as well. They just control the key distribution, but if you have physical access to the door handle, then all that is off. and that doesn't work anymore. It's also not access logged either. Usually they do have fancy electronic locks that whenever you use the key, it logs it, but most of them do not do that. So any questions about things I probably don't know how to answer? Of course, Mr. Davey.
I just want to know immediately when you run into a doorknob that this key doesn't work on. I'm expecting you're going to find a milk crate somewhere just full of keys, and I'm just curious about that.
I have already found them. There's a few lever locks that I believe we got from the old Rogan Shoe building or whatever the other, like old Madison College West Campus building. And these obviously are totally different. So, and I've tried bumping those, and I'm nearing the point where I mailed them to Scott, but I figured I should bug Kevin locally and see if Kevin wants to try picking them first. Although Kevin and I think are pretty even on the lock skill, but Kevin may outweigh me in his ability and willingness to throw time at a problem right now. So I might bug him and see if he's looking to get back into picking locks or not.
Scott's on sabbatical.
Oh my God, don't tell me that. FedEx is, or USPS is way too cheap. We'll get a flat rate on the way. Anybody else have any other questions? I feel like if I was going to give these to Scott, I'd have to like dry out the lock just to make it hard, just to give him like something to like, he wouldn't realize like you had to tension it like a gorilla turning the thing. And that would be the way I could get him to take more than 3 seconds to pick them. That might be his only undoing. I'll throw some like sand in the back of it or something just to add on a little difficulty level.
Since we moved here, we've saved the neighbors a couple times, and like the contractors, the landlord brought in people to take the door off the hinges, and Scott was like, "Okay, if you're gonna take the door off the hinges, let me just try. Come on."
Yeah, and like 3 seconds later, it's unlocked, and the guy's going, "Why?"
Exactly.
It doesn't seem like a good introduction to the neighborhood. Like, "Hi, I'm your new neighbor. I can pick any lock around. Just FYI, I'll be right there."
Well, yeah, you don't tell anyone that until they're like they're waiting for you, like outside there in the atrium, and you're like, "What are you waiting for?" Like, "Oh, I've got to call the locksmith. It's going to take 45 minutes. I'm just stuck outside here." And you're like, "Okay, well, let's just so you know, you could if you want to, you just get in there."
Yeah. Finding out about the reality of locking systems is one of those naiveties that gets stripped away when you peel back the layers of reality and society and things like that. And then when you start realizing that safes are rated in just how much time it takes to get into them, like at least they're front about that. Like when you go to Home Depot and you're buying things, there's the good, better, best. And they can't really explain to you why you would want the best versus the good or the other one. And
all the Home Depot locks suck. The other interesting thing is as you're rekeying these, and if you guys are interested, we have a full rekeying system, like a whole kit. But you can drop in, they're called spool pins or mushroom pins, and those make it a really huge pain in the ass. Or if you take a bunch of master pins and you stack up all those little tiny ones, it makes it really much harder to pick. Because you're adding more inner spots, and sometimes it makes it easier, but it also makes it harder depending on how the lock works. Also, interestingly, a new lock is really easy to pick, and a really old crappy lock, really hard to pick. So if you have like a worn out, busted ass lock that like barely works with your key, that's the one you want. If you have a brand new fresh lock that like slides in real nice and just turns super crisp, that's the one that's like easy to unlock. But as I tell everybody whenever we're out doing the lock picking stuff, your door is as good as the window next to the door, or usually the window in the door, which means that it doesn't make any difference. Unless you're going to put up window bars, your door lock is of no value anyways. It's too easy to go through a window. So that is what it is. I got one other thing I can share real quick, unless somebody else has anything that they wanted to do. All right, this one's just a set of pictures. So Jim has had me, and I'm convinced I am effectively just slave labor to Jim at this point. So is this, nope, not that. You go away. Let's see. Can you guys see my Google pictures here? All right, cool. Oh. When I hit share screen, it like threw all of my desktop everywhere. So anyway, so this is what these are mask fitters that we're making. Up here at the top, you can kind of see one with the funky bend and the green thing with the string coming out of it. What it does is it makes your mask fit tightly around your nose and seal to your face. So if you have a surgical mask that you're wearing, or like a KN95, this will make it so that it fits tightly to your face and stays better sealed, which helps with like keeping your glasses from fogging, keeping you from inhaling a nasty virus, things like that. So as you're making these things, this is a workstation that Jim has built to make these. And what I'm mainly doing now is cutting up all the materials. So the issue is that we need to cut up like thousands of these, not like dozens or hundreds anymore. We need to make lots and lots and lots of them. That's Tesla for scale. She is sadly missing all of you guys, I think, but as in typical cat sense, I'm sure if anybody's back, she will totally ignore you for 2 days anyway, so it's not going to matter much. But at any rate, so what I ended up doing then is setting up this thing. This is an old auger blade in slow motion, dramatic effect. It's actually an ice auger blade. And so it's like what you'd auger a hole through the ice in the lake. This is the corner that's on the auger portion of the flight. And I took the razor blade off and put it on a little pneumatic slide we had laying around. And then this thing in piece on the right is just a chunk of HDPE and it's something slippery to slide through. And so what this is able to do then is make it so I don't have to hand cut these things with scissors anymore. I can just have this thing chop them for me. So the first version was just hand feeding the material in. And so essentially just pushing it down to a stop, having a foot pedal that you could step on to trigger the pneumatics, and then just cut tubes for you that way. And so this works okay. But as the tubing gets unspooled off the spool, the tubing starts to curl. So this is the very beginning of the roll. And so the tubing's really nice and straight. But as the tubing gets to the end of the roll, it curls away from that stop, and it ends up cutting too long. As you get in a hurry, you end up triggering the cutter too soon because it bottoms out, but as you get more curl, it gets harder to push, or the tubing folds over. So you're like trying to shove it down and hit the foot pedal, and it feels like you stopped, and so your brain hits the foot pedal and you chop off one that's like 1 inch long instead of 2 1/4 inches long. So I was looking at 3D printer extruders and thinking, well, an extruder is just a way of moving a plastic tube, and I have a really long plastic tube that I want to move. So why don't I just put an extruder feeder that's scaled up on this thing and let it sit and run? So the first step is I needed a way to drive a stepper motor. And so this is something that Mike Sulgrove built a long time ago. It was a linear camera dolly. So he made this little tiny camera slider. And we like, as we were moving, I ran across this thing. And so I kind of threw it in the electronics box and realized that thing's still sitting around. So I went and grabbed it. And so I set this up, and so this is just feeding down, and then it pauses for just a fraction of a second and triggers the cut. And so I don't know if you guys can hear the lovely clicky noises, but it just sits and chops and chops and chops and chops and chops. There is some inconsistency on the feed because it's an open loop system. So I'm just commanding the stepper to step a certain number of times and then cut, assuming that the tubing feeds each time. And it feeds within like 1/4 inch, which for our product is good enough. I'll speak for Jim, only because it would be a lot of labor otherwise to not do that. So this is kind of the whole system running. So I just put a spool above it. The spool is slowly getting sucked in, getting driven down. And I thought for sure I'd have to put some better guide structure below that, but it turns out the vinyl tubing is stiff enough. It doesn't really have any problem pushing down without kind of squishing sideways like filament does on the printer. And then I slowed it way down because we're after more consistency than we are throughput, because this thing can make about 1,000 masks worth in like an hour. So we don't need to have the thing running like full tilt. Also, it lets me push my production numbers up when Jim demands like higher throughput, a classic manager. I can like bump it 5% every week or every month and just like, oh yeah, I'm working extra hard back there this month. We're really going to push through a little bit more, but I just don't know if we can go any faster. And so with that thing working, I decided to move into the next opportunity, which was cutting this other wire, which was a little bit harder to cut. It's the green stuff. And so I grabbed a pneumatic cylinder from upstairs. I needed a pivot point on the cylinder because if you off center load a cylinder, it'll bend the rod and your rod will bend in half. And then so I put a clevis on the end, or a Heim joint is what this thing is called. And so it's like a ball bearing swivel, again, to make sure there's no load ever on the cylinder. And of course, the cylinder needs some goofy ass 3/4 by like 20 fine thread. And we had no bolts or nuts. And so I made a nut. The pandemic pushes you to have to, sacrifice things and it was just because I was lazy and didn't want to have to order parts and wait for them. So this is kind of the rough framing. I took the crappiest pair of side cutters in the drawer, which turned out to be a mistake. I should have started with nice side cutters, but I wasn't sure if it was going to work or not. And then I just used 2 rope stops. These are like the things you fold over wire rope and clamp. just to clamp on to set the range of motion for this clevis to kind of float on the handle. So this is our OSHA certified cutting device. It's OSHA certified in the sense of if you keep your fingers out of it, you'll be totally safe. So I mean, as long as you got your fingers free, it's no problem at all. It's one of those, I built the thing and I'm the only one running it, so I don't feel the need to make it more obstructive than it needs to be, at least right now. So manually, I'm just pulling it off, hitting a stop, and chopping it. It's hard to do with one hand, and also was later found to be, I sharpened the pliers and it made it work for quite a while, but it ended up being a better idea just to get a nice pair of side cutters. So I begged Jim to let me, order a decent side cutters. He kind of waffled for like 2 weeks, letting me have to suffer through using these ones. But we eventually got some very nice, made in the US, channel lock brand side cutters that cut through this thing like butter. So it works quite a bit nicer. So this is what I ended up with this afternoon. I built a second feeder. You can kind of see the other feeder in the back left. And so preliminary testing, it seems to work okay. I'll have to run through a spool and kind of supervise both these things and see how much variability we get. But honestly, the material is so cheap. Even if this thing makes a defect every 30 or 40 of them, it wouldn't make any difference. It also doesn't have to be that precise in general. It's just something you're going to bend up and stick in your face anyway. So you're going to kind of end up custom making it to fit however you want. And before anybody asks, you guys always come to me and you're like, oh, I need to use this like fancy automated tool because I spent all this time designing this part. So I designed the whole thing in Fusion, and then I got out a punch and a hammer and printed off on the 8.5 by 11 my templates and punched them. And whenever I punched them off center, I just translated all of the bolts off center and punched them all anyways, and it worked out just fine. So I don't want to hear anybody whining, that they don't have all these fancy tools to use because of the pandemic. Just get out the punch and the hammer and a drill press and you're in good shape. So Dennis, you're like 99% of the way there with a drill press now in your garage.
And we can Dremel the edges, so yay.
That's exactly right. Thank you. See, this is all you need to know. Anyway, so I thought I'd share that. It's the first time I've ever built a fully automated thing that I felt like I could walk away from and have it continue to run mostly. And that's mostly true. It ran for like 2 hours before Jim came and said the thing's making a different sound. I think something's wrong. And the little nut holding the bearing on the idler arm had unwound itself. So I swapped it for a lock nut. I figured that'd be a good reminder to like check on it when the nut fell off, and it worked out pretty good that way. So I put a new nut on and it hasn't had to be poked at yet, but we'll find out.
I fear for Tesla being near that thing.
She hates air noises, like hissing noises. So she's like miles away. As soon as that thing fires once, she will not come in the whole back half of the shop for the rest of the day because she's done with the giant snake that clearly must be lurking in the wood shop.
So I have an OSHA story. Just we need to keep it among ourselves here, and I'm pretty sure
you're being recorded.
Yeah, I was going to say maybe wait till I turn off the recording.
No, it's not nearly as bad as OSHA as you can find online. Don't worry. But any machine that can do pinch, something you don't want to have your hands on, the standard is to have 2 buttons. So the worker can put a piece under the fixture and then reach over here and hit 2 buttons. If you only hit 1 button, it doesn't do anything. And so, that's what keeps your hands from getting pinched. And so many, many years ago, like I said, way before the statute of limitations, I did software for a machine that did some fancy stuff to a unit under test that had to be clamped down, and because of the clamping action, it had the 2 buttons. And the operator had been using this for a very long time. We designed it back in the lab, brought it out, it had been in production for a very long time, and we had a small change to make. Usually, things would get taken off the line, brought back into the lab, and we would make the necessary changes. But this was a small enough software change, I could just go out to the machine and make the software change. And so, I let the operator know that we needed to make a change. Everybody, had to back away from the machine and everything. And I hooked up my programming dongle to it and made the software change. And then to test it, well, since the dongle was already on there, I just stepped through the program to do the unit under test, which meant I was able to step right into the routine that caused the machine to function without the 2 buttons being held down. And these are the two buttons that this operator has trusted their hands to for months and months and months. And here's a naive little engineer who, visually inspected to make sure nobody was near the machine and hit the button that, stepped into the code. But when that machine came down without those two buttons being pressed, that operator's face just went completely white and their eyes got as big as saucers. And I couldn't figure out why. And I'm like, no, it's okay. It's because I have the programming dongle attached and everything. And, we were able to disconnect it and show that it only works with the buttons and everything. But I don't think they ever trusted that machine again for the rest of their time with the company. So that's a lesson learned.
I've been in manufacturing plants where they have a nice lever taped to the second button. So that she still got one hand free. So it's compliant, but it's not actually compliant.
Oh, that's terrible.
So a lot of places I've also seen where they have guards on top. So you have to put your hands up and then push to prevent you from being able to wedge something in. But then people just shove cardboard in to hold the button down. So, I don't know. It's just,
Never underestimate the capacity of lazy people.
Or people who are tired and sick of pushing both buttons and holding their hands up or whatever it is. But yeah, definitely.
Yeah, if you try to make it foolproof, they'll just be, oh shoot, I forgot the punchline. There'll be another fool to prove it. That's it.
All right, well, I think that's all that we had that I knew about. Does anybody else have anything they wanted to share or mention?
I'm not going to talk about it today, but maybe next month I'll tell you about my my super awesome it's like a searchable index of whatever inventory concepts. I've got a couple different like spreadsheets where the Google spreadsheet is the back end. So it's like a free, nice, responsive web app that you can embed as an iframe and you can, search for whatever. And it doesn't cost me anything and I don't have to run like Drupal. So yeah.
I'll sign me up. A friend of mine in college built a thing called Upkeep. And Upkeep was a facility management tool that he built for his church that you could have like, in this case, it was like a vehicle. So like their bus. And so you'd set maintenance intervals on like changing the oil in the bus. And then every 6 months or every however many thousand miles, because they also had the guy using the odometer logging every time they took the trip with the bus. And I was in college and I was like, why the hell would you ever need this thing? Like, well, what the hell's, why don't you just keep some notes or something? Like, it's easy enough. I mean, no big deal. Now having a facility with like a billion tools and all sorts of crap and all sorts of stuff that needs to get greased every so often, all the rest of the stuff. I wish I should probably just go harass him, but it's all written in C#, so I'd be hopeless at setting it up and doing anything with it. But so maybe I can inspire Shira or help with Upkeep 2.0. Maybe got a good name already. I can go get the little logo from him.
If you write the spec out, the specification, I maybe when I get bored, I'll open up a Google Apps script and make it for you.
I'll just beg Sean. I think Sean's got the ropes on programming figured out now. So, oh, I can't make fun of him if he's not here. That's no good. Anybody else? All right, we can give up for the